Alright, in this video we are going to discuss the tryout problems from Meet 1. We're going to start with the easiest one first, which one do you think was the easiest? Probably numbers, event 3. What is the maximum number of slices of pizza you can get by making 100 straight cuts? Express your answer in base 6. So let's get the cuts first part. So obviously, since this event is titled patterns, we're going to look for a pattern. So you have a pizza. You make one cut. There's 2 slices. You make 2 cuts. You get 4 slices. You make 3 cuts. Now, how can you make a straight cut to get the maximum amount of pieces? So you don't want to cut it through this intersection point, so you want it like that, yeah, something like that. So how many pieces is that? 1, 2, 3, 4, 5, 6, 7, 7. I think I'm starting to see a pattern. What about 4 cuts? Well, you can kind of guess right around this pattern. Add 2, add 3. You can probably guess that it's 11. But let's make sure. How can I make sure I get the maximum number of cuts? You probably want to cut it like, see how I intersected 3 lines like that? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now I think that's enough to see the pattern. Now, how can you tell what the formula is going to be? Well, we have this thing called the method of finite differences. What's the difference? So basically you have a sequence like this. What is the formula for the sequence? Well, what is the difference of the terms? Here we got 2, 3, 4, and 5, and so forth. And then now you look at the difference of the differences, 1, 1, 1, 1. If it takes 2 levels to get to a constant difference like this, then you know the formula is going to be quadratic. If it takes 3 levels, then it's going to be cubic. If it's just 1, then it's going to be linear. So since it took 2, the formula is going to be of the form an squared plus bn plus c. It's got to be quadratic. See, second power is the highest power. Now, how can I figure out these numbers? You can guess and check if you want, but we have a mechanical way of figuring it out. If I plug in 1 into this formula, shouldn't I get the first term, which is 2? So a plus b plus c equals 2. If I plug 2 into this formula, you should get 4. So 4a plus 2b plus c equals 4. If I plug 3 into this formula, you should get 7. So 9a plus 3b plus c equals 7. You have 3 equations, 3 variables, and you just solve them. So the easiest way is go, look, call this equation 1, 2, 3. Just notice that the coefficients of c are all 1, so if you just subtract the equations, the c's will cancel out. So 2 minus 1. 3a plus b equal 2. Then you go 3 minus 2. 5a plus b equal 3. Then you go this minus this. 2a equal 1. Therefore, a is 1/2. Take that and plug it back into one of these. Let's say this one. So b is 1/2. Take these 2 and plug it back into one of these. Probably the first one is the easiest, so therefore c is 1. That means the equation was f equals 1/2 n squared plus 1/2 n plus 1. There you go. There's a mechanical way of figuring it out. Now, some of you might have been able to figure this out because, look, it's like n times n plus 1 all over 2 plus 1. Hey, that's the formula for the triangular numbers. Right? And then you add 1. So in other words, these numbers, I don't know if you guys noticed, but did anyone notice that these numbers are just 1 bigger than the triangular numbers? Look, isn't this 1 plus 1, 3 plus 1, 6 plus 1, 10 plus 1? 1, 3, 6, 10, those are the triangular numbers. In fact, after I talk about this, after we finish this problem, I think I better talk about triangular numbers and square numbers and pentagonal numbers and so forth. Alright, so now that we got the formula, so if you make 100 straight cuts, all you have to do is plug 100 into this formula. So would I rather plug in 100 here or there? I think this one might be easier, yeah? 100 times 101 over 2 plus 1. So that goes into that 50. So what is it going to be? 5050 plus 1, 5051. There you go. So if you get that, you get half the points. Now, we need to convert this into base 6. So how do we do that? Well, in base 6, you have the 6 digits, 0, 1, 2, 3, 4, 5. Okay? The first one is the 6 to the 0 place. This is the 1's place. This is the 6 to the 1's, which is 6th place. 6 to the second power is 36. 6 to the third power is 216. 6 to the fourth power is, what's 36 times 36? 1296? And I don't think we need over there because the number is not big enough. So how many 1296s will go into 5051? 4? No, 4 is too much. It got to be 3. Huh? So 1296, 8 times 3 is 8 carry 1 carry 2, 3. 3888. Subtract that from 5051, 3888. 3, but we got to borrow, so that's a 6, 1. Oh, we could have done one more then. Oh, got it. 12, that's stupid. 1296 times 4. 4 carry 2 carry 3. Wait, I'm tired after lunch. Carry 2 carry 3, 1, 5, 1, 8, 4. That's too much. 5184 is bigger than 5051, so it has to be 3. Did I do something wrong? Okay, let me multiply this out again. 8 carry 1 carry 2, 3. Subtract, maybe I'm subtracting wrong. 3, 6, 1. Oh, gotta borrow. That's a 1, you dummy. I had problems borrowing. So, 3 of these will go into 5051. Now there's 1163 left. So how many 216s will go into that? I'm guessing 5. 216 times 5 would be 0, 8, 1080. Hey, I got it down. So subtract, what do we got? 3, 8, 83 left. So was 5 of these. Now how many 36s go into 83? 2, that one's easy. 72, subtract, you get 11. How many 6s go into 11? 1. And then how many 1s? 5, there you go. So the answer is 35215 base 6. That's your answer. Okay, so the problem wasn't that difficult if you knew this. Yeah. So the title of this event is Patterns. Look for a pattern. And here, this method of finite differences gives you a mechanical way of figuring things out. But that's only if you look at the difference and it gets down to a constant difference. Sometimes you can keep on taking differences and you'll never get to a constant difference. Now, this thing I was talking about triangular numbers and square numbers and so forth, there's a pattern to that. I'm going to show you this pattern. So, 1, 3, 6, 10, 15. Why do we call these the triangular numbers? Because they form triangles. See, 1, and then 3, and then 6, and then 10, just like bowling, and then 15. Okay, there you go. And what's the formula for the triangular numbers? Here, I'll just tell you. N times n plus 1 over 2. This is something that you should just know. Or, if you multiply it all out, that's 1/2 n squared plus 1/2 n. Now, making triangles, the next thing would be square numbers. What are the square numbers? 1, 4, 9, 16, 25. Now, why do they call these the square numbers? Because they make squares. Look, 1, then 4, 9, then 3 by 3, or 4 by 4 squared, 16, and so forth. And of course, we know the formula for the square numbers is n squared, right? Duh, that's why they call it the square numbers. But if we write it in this form, it's 1 n squared plus 0n. Now, there's a pattern to this, and you know what, to save time, I'm just going to tell you the pattern. So, pentagonal numbers are numbers that form pentagons like this. 1, you always start with 1. And then to make a pentagon, like that, then you need 5. What do you think the next one's going to be? So you make it, each side is of length 2, like that. 1, 2, see? So 1, and then see? And then do. How many dots is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Pentagonal numbers. Now what's the formula for that? Well, look at the pattern. The coefficient of n squared increases by 1/2 and then the coefficient of n decreases by 1/2. So if we follow that same pattern, it's going to be 3/2 n squared. What happens if I subtract half? Minus 1/2 n. Boom! Now does that work? If I plug in 1 for n, do I get 1? If I plug in 2 for n, do I get 5? Let's try that. 6 minus 1 is 5. If I plug in 3 for n, do I get 11? Duh! Why would I teach something that doesn't work? Alright, and then let's just do one more. What about hexagonal numbers? If we still follow the same pattern, increase that by 1/2, 2n squared, and then subtract the half from that minus n. Boom! And we can continue that for septagonal, octagonal, nonagonal numbers and so forth. So that's the pattern. That's the title of this event, patterns. Alright, the next toughest problem was, I think, the next easiest problem. I think it would be number 5, event 5, the sets. Now, when we graded the papers, hardly anybody even drew a Venn diagram. What is the meaning of this travesty? This problem is pretty darn easy if you draw a Venn diagram. Anyway, that's the title of this event. It's sets. You want to draw a Venn diagram if possible. So, your Venn diagram should look something like this. These are the numbers that are multiples of 4, 5, and 6. Here, 4, 5, and 6. And sometimes you need to put the universal set because sometimes you have numbers outside of there. Now, given all the natural numbers from 1 to 777, I better write that down so I don't forget. How many multiples of 4 are neither, so here are the multiples of 4 right there, are neither a multiple of 5, so that means outside of 5 and outside of 6. So that would be right here. Yeah. So if we can figure out how many elements are right there, this problem is done already. Now, just like with all Venn diagram problems, you want to figure out this middle one first. Always do that. So, basically, how many numbers are multiples of 4, 5, and 6? Well, if a number is a multiple of both 4 and 6, that means it's a multiple of 12, right? And then if it's going to be a multiple of 5, that means it has to be a multiple of 60. So how many multiples of 60 are there from 1 to 777? The fastest way is divide. 777 divided by 60. Let's see if I can do this correctly. 17 remainder. So 170. 60 goes into 177 2 times. Gosh, I'm slow today. So that means 12. 12 of these numbers are divisible by all 4, 5, and 6. Now, what about numbers that are just divisible by 4 and 5, which will represent this there? Well, if a number is divisible by both 4 and 5, that means it's divisible by 20. How many numbers are there over here? Well, divide. 777 divided by 20 is 20 goes into 73 times, so that's 60, so that's 177. 20 goes into that 8 times. Okay, I hope that's right. Okay, so 38, that means everything in here got to be 38, but that's 12, so doesn't that make this 26? And you keep on doing it until you can figure out there. Okay, now what about right there? That's how many numbers are divisible by both 6 and 4. That means divisible by 12. So 777 divided by 12. 12 goes into that 6 times, 72, 57. 12 goes into 57 4 times. So everything in here has to add up to 64, but that's 12, so therefore this got to be 52. Is that right? Hope I'm doing this right. And then finally, easy. How many numbers are divisible by 4? Just divide again. 777 divided by 4. 1, remainder 3, 9, remainder 1, 4. 194. So everything in here got to add up to 194, but what do these add up to? This is 38 plus 52. What did I just say? 52 plus 38 is 90. So this is 90, but everything in here got to add up to 194. Therefore, what does that have to be? 104. Bam, that's the answer. Venn diagram. Yeah, let me give, and remember now on the website there's notes. So one of the most important notes is if you have a set A which has elements 2, 3, 5, 7, 11. They're the first 5 prime numbers right there. How many subsets does this set have? Well, the answer is, since there's five elements in this set, the number of subsets it has is 2 to the 5th, which is 32. And you know why that is? That's because this number can either belong to it or not belong to it. It has 2 choices. Same thing with that, and that. That's why 2 times 2 times 2 times 6 times 2, 2 to the 5th. Now remember, what is a subset? A subset, just remember this. The empty set is a subset of every set. That means the empty set is a set with nothing in it. That is also a subset of that. So that counts as one of the 32. All right, the next easiest problem, I guess, would be geometry. Now, a lot of people did not do well in this one. This event could be tough. Just drawing the picture could be tough. So in triangle ABC, with E on AC, here's E, and D on BC, D, angle ABC is equal to angle ACB. So you should indicate that those 2 angles are equal. AD, segment AD, is congruent to AE. So if this segment is congruent to that segment, that means this angle is congruent to that angle. Right? When 2 sides of a triangle are equal, the 2 angles opposite those sides are equal as well. That's the key. That's the number 1 key to this event right there. And the measurement of angle BAD is 62 degrees right there. Find the measurement of angle EDC. I'll call that X since we're trying to find that. Okay, now what you need to do is you need to start writing equations. Okay? So these 2 angles that are equal, I'm going to call that Y, or you can call it whatever you want. And these 2 angles that are equal, I'm going to call that Z. Start writing down equations, and then what you got to do is you got to get good at combining these equations to solve the problem. Okay, so can somebody tell me what equation can I write here? Well, here's another thing that comes up in this event. If you have a triangle and an exterior angle right here, what should I call it? A. The exterior angle is equal to the sum of the remote interior angles. Angle A is equal to B plus E. That comes up a lot also. So, can you see something in here where I can use that? Yeah, right here, look at that. If you look at this triangle, ABD, this angle here is an exterior angle. So, X plus Z has to equal to the sum of the 2 remote interior angles, Y plus 62. See, now we have somewhere to start. Okay, we got with that. Now the key is, we need to solve for X. How can I get that? Well, we need another equation. Can somebody see another equation we can use? Yeah, look at this. Here's a triangle right here. Look, the exterior angle is going to equal to the sum of the 2 remote interior angles. So that means Z got to equal X plus Y. Now there's so many different ways of doing this problem, but you cannot just stare at it. You got to start writing down equations. That's what you got to do. Now, is there a way I can combine this to solve for X? Because look, if I solve for X, X equals Y minus Z plus 62. Hey, I can do something with this because look, if I manipulate this equation, Y minus Z equals negative X. So this is negative X. Oh, which means 2X equals 62, X equals 31. Woo! There you go. That's a typical problem in this event. So, label the angles that you know are equal and then start writing equations. None of this guessing and checking business. Alright? Yeah, so those are the JV events. Now we got tougher events, but some of you are in those. And by the way, even if you're in JV, I want everybody to do number 6. Because, especially the veterans, you know that being successful at Math League means you have to be good at algebra, and that's what number 6 is. So what I have here in number 6, I have like 5 factors. Each one is simplified, and once you simplify each one, then you can start canceling like a mad dog, and the answer comes out to 1. That's my trademark. I love to make problems like this where you got a lot of different factors, but they all cancel out and you get something nice. Now I'm just going to do one for you, okay? I'm going to look at the second factor. Let's just simplify this one. Because some of you like just gave up, man. We can't give up. Well, I guess if you only have 30 minutes, then you might have to give up. Okay, let's simplify just that one, okay? Because if you can simplify this one, since it's the hardest one, you can simplify the others. Okay, so what do I do? Like right there. What do you do when you add fractions? You make the least common denominator, which is? Or, do you want to do each one first? Or do you think I should make the least common denominator of the whole thing first? That's what you have to decide. It doesn't matter to me. It looks like it doesn't really make that much of a difference. Shall we make the least common denominator for the whole thing? Or do you want to just simplify that one first? Oh, you want to do that one? Okay, let's do that. Simplify the top first then. Least common denominator, then on the top you get y plus x. Now when you divide by something, that's like multiplying by 1 over it, so that means it's going to go in the denominator right there. X squared minus y squared. Okay? Minus. Now look at this one here. Make a least common denominator, xy. What goes on the top? Y plus x. And then when you divide by that, it's going to go in the denominator, x squared plus y squared. I copied the problem correctly, didn't I? I don't want to make any mistakes here. Okay, so there you go. That's kind of ugly. Now you have a regular fraction, make a least common denominator. Now yes, some of you are thinking, yeah, I can cancel over here already. You want to do that? You want to factor this as x plus y times x minus y, and then cancel these out? Well, too late, I already did it. So what do I have? 1 over xy, x minus y, minus y plus x all over xy, x squared plus y squared. So when you subtract fractions, you make a least common denominator. See, what you want to do is, your goal is you want to factor everything, so then you can just start canceling. So what's going to go in the numerator here? X squared plus y squared, minus, and then you have y plus x times what's missing here? X minus y. Right? Yeah. Okay, so what happens when I multiply out the top? You get x squared plus y squared minus, well, this is like x plus y, so when you multiply it, you get the difference of squares, so you get x squared minus negative y squared, so plus y squared, all over xy, x minus y, x squared plus y squared, and then pogo, so this combines to 2y squared. And then you can cancel, right? So what's left? This y cancels into that, so you get 2y all over x, x minus y, x squared plus y squared. Whew. So that's that one, and then you can combine it with other things later on and start canceling. Okay, some other tips here. Differences and sums of cubes. You gotta know that. You gotta be good at cubes. So when you see this, you factor x minus y, x squared plus xy plus y squared. What about sum of cubes? X cubed plus y cubed. That would be x plus y, x squared minus xy plus y squared. That comes up a lot in Math League as well. And then also look at the third factor. Just this part of it. 1 over y plus x squared over y. Now I don't know if you know this, well everybody else should, but the 9th graders, the simplest way to simplify a complex fraction when you have fractions within fractions is to multiply top and bottom by the least common denominator of all the fractions you see. So like see, this is over 1, this is over 1. The least common denominator is y. Simply multiply top and bottom by y, and you're going to get y over y squared plus x squared. Bam! And then you don't have a complex fraction anymore. Just like this. Like what if you had 2/3 plus 3/4 all over 11/12 minus 1/2? The fastest way is to multiply top and bottom by the least common denominator of all the fractions you see, which is 12. So if you multiply this by 12, you get 8. Multiply that by 12, you get 9. Multiply that by 12, 11, you get 6. So the final answer is 17/5. Boom. Really quick. That's how you deal with complex fractions. Okay, let's look at event number 1. Now for this event, you have to know some things. If you have a quadratic equation, like this, there are 2 roots. The sum of the 2 roots will always be negative b over a, and the product of the 2 roots is always going to be c over a. That is critical to solving this problem right here. So, a quadratic function, now, see, that's the difference. This is a quadratic equation. A quadratic function is y equals ax squared plus bx plus c. Or you can put f of x there, same thing. Okay? Now, if it passes through the points 1, -4, and -2, 20, what do you think I'm going to do with these 2 points? You plug it in. If you plug in 1 for x and -4 for y, you get -4 equal a plus b plus c. If you plug in this point, you get 20 equals 4a minus 2b plus c. See, now you can start working with the equation. And then the product of the zeros is -2/3. So if the 2 zeros are R1 and R2, if you want to call them that, then you multiply them together, what are you going to get? C over A. So we know that C over A is -2/3. So it says find the sum of the zeros, which would be negative b over a. So basically, you just got to figure out what a, b, and c are, and you can answer this question. Well, right here I have an equation with 2 variables. So what do you want to do? C and a. Right here. So what you want to do is you want to get rid of the b here so that you can just have an equation with c's and a's. So if I want to eliminate b, I'm going to multiply this equation by 2 and add. So what do we got? -8 equal 2a plus 2b plus 2c. Add these equations and you get 12 equal, what is that? We're adding, yeah? 6a, the b's cancel out, plus 3c. Divide by 3. 4 equal 2a plus c. There, now you got 2 equations, 2 variables you can solve. So c equals -2/3 a. Take that and plug it in there. -2/3 a. So 4 equal 2 is 6/3, so 4/3 a. A equal 3. Plug it back into here, c equal -2. And then how can I find b? Go back to this equation here. A plus b plus c gotta equal -4. So -5. Okay, so the sum of the 2 zeros is going to be negative b over a. So negative b over a, that's 5/3. See how like almost all the problems involve algebra? That's what you got to know for math lead. Algebra, you got to be good at it. Well, that goes for any math subject, right? Algebra 1 is still the most important course there is for mathematics. It builds the foundation for everything. And then finally, the trig problem, kind of disappointing because I thought we would have done better than this. All you gotta do is use half angle, that's why. So I'm just gonna do one for you. I'll just do one of these. Okay, how about this one, pi over 8 then? How do you compute sine pi over 8? Well, anytime you have pi over 8, the only way you can compute it is using a half angle identity. So, sine of x over 2 is equal to plus or minus the square root of 1 minus cosine x all over 2. Now, how do you figure out whether to use the plus or minus? You have to look at the quadrant of that angle. Well, pi over 8 is in the first quadrant, sine is positive. So, it's going to be positive 1 minus, before we even start, sine of pi over 8 is half of what angle? Pi over 4, right? Now we can apply this identity. So it's going to be positive square root 1 minus cosine pi over 4 all over 2, which is the square root of 1 minus root 2 over 2 over 2. multiply top and bottom by 2 inside the radical, and so you got the square root of 2 minus root 2 all over 2, because the 4 comes out as a 2. There you go. That's what sine of pi over 8 is, and you simply got to raise it to the 4th power, which means square it twice. So square it once, what do you got? Square that once. 2 minus root 2 over 4. Square it again, and you're going to get 16 on the bottom, and what's that going to be on the top? 6 minus 4 root 2. Did I do that correctly? Of course, I'm a teacher. And then, of course, you can compute each one, and then just add them together. But then if you think, you can save you time, because sine of pi over 8 and sine of 7 pi over 8, aren't they the same value? Right? The y-coordinate here is the same as the y-coordinate there. So that number and that number are going to be the same. And same thinking, these two are going to be the same because 3 pi over 8 and 5 pi over 8, the y-coordinates are going to be the same number. So basically you just have to do this and that and just double it, and that's the answer. And also Jason Cho has another solution using identities, so I will attach that to the email I'm going to send you with this video. All right, let's get the job done.